Good evening, everyone. This is Terrence. I'm going to be giving a presentation on near-surface soil moisture fluctuations using BDS SNR observations. The results are from low vegetated surfaces. So just kind of an outline over some of the topics I'll be talking about. Be looking at the research objective of the study. I'll also be talking about the methods, the results, and then looking at kind of the importance of the study. Why is it important to study soil moisture fluctuation? And then also looking at my own relevant experience with remote sensing technology. So the experimental site was located in Dari County, Qinghai Province, which is the northern part of the Tibetan Plateau. Site characteristics included low vegetative index and high elevation, which were carefully selected variables as part of the study. So why choose a site with little vegetation? Well, depending on the remote sensing analysis being conducted, study areas with lots of vegetation or high vegetation indexes introduce a lot of noise to the data. This is something that is measured. It's an equation. It's actually called the NDVI, and it's used in remote sensing to determine kind of the canopy growth, how much vegetation an area has. And really, this is something that's looked at. It's just depending. It really just depends on the kind of study that's being conducted. So, what's your research objectives, and then also the remote sensing application. What kind of instrument is being used. The instrument being used and also the research objective will kind of influence your decision as to whether the location or site has to have a high or low vegetative index. So the goal of the study was to determine the feasibility of using China's Baidu navigation satellite system, signal-to-noise ratio, for estimating soil moisture fluctuations. The soil moisture data was collected using both the B1 and B2 frequency bands. B1 has a frequency of around 1500 megahertz, and then B2 has a frequency of around 1200 megahertz. And then here's just a graphic just kind of showing where microwaves fall on the electromagnetic spectrum there, wavelength, frequency, and then also their remote sensing applications. Two methods were applied to model BDS observations. The first method was the phase method, and then the second method was the interference method or model. So looking at the phase method, basically the main theory behind it is the interference mode between direct and reflected signals under multi-path conditions. Signal-to-noise ratio oscillations depended on the reflectivity of the land surface, which is also related to the relative permittivity, which we'll kind of talk about a little bit more here. The receiver could basically retrieve information associated with near-surface soil moisture changes by recording temporal SNR or signal-to-noise ratio oscillations, and then use the phase difference between the two signals. An interferogram or interferogram product would be created, which is kind of similar to how INSAR works for measuring small land elevation changes. Interferometry also uses the phase difference as well to determine small slight elevation changes, and then produces a DEM as a result. So with the interference model, retrieved soil moisture data was based on simultaneous reception of the direct and reflected signals. And this required a specifically designed ground receiver called GNSS-R, and basically GNSS stands for Global Navigation Satellite System. And then the three variables that determined this data was reflector height, the relative permittivity, and then the elevation angle as well. So talking a little bit more about relative permittivity, basically what happens is a source or a sensor releases energy on the electromagnetic spectrum, and this wave comes into contact with a medium or sample. Then that sample has the potential to affect the propagation of that wave. Can attenuate electromagnetic waves that pass through it, and then affect the propagation speed. So basically, how the wave propagates back to the sensor that released the energy in the first place. So basically, low permittivity will result in high signal propagation speeds, and then high permittivity will equate to lower propagation speeds. So the relative permittivity or the sole permittivity for the study was used along with precipitation data, which they found a lot of correlation with. There was very high correlation between the precipitation events and the increase in soil permittivity. And then basically the authors also indicate that the relative permittivity can be used as a direct measure of soil moisture just based off of empirical studies that were conducted. So kind of looking at the results briefly here, 6 significant precipitation events were recorded as part of this study. Both BDS and GPS results demonstrated good agreements with the precipitation. Correlations were made between the estimated relative permittivity and the phase shift of B1 and B2 bands. BDS B2 had a correlation coefficient of 0.68, and B1 had a correlation coefficient of 0.62. So B2 showed higher correlations with relative permittivity than B1. And then the results also indicated that the interference method was more sensitive than the phase method for dry soils. So the estimated results from the phase method showed good agreement with in situ precipitation data. So just overall, generally speaking, the soil permittivity correlated well with increased precipitation using the BDS B1 and B2 frequencies. So looking at the importance of studying soil moisture fluctuations, why is it important to study soil moisture fluctuations? Well, soil moisture impacts other hydrometeorological variables. If you have taken a basic course in hydrometeorology or hydrology, you understand that there is an energy flux involved, so thermodynamic principles are at play. So soil moisture, ground level moisture has an influence on those fluxes, which overall influences the hydrological cycle. Understanding soil moisture fluctuations and being able to identify soils with varying amounts of moisture over a large temporal scale and spatial scale as well will have significant implications for the agricultural industry. So determining locations for growing crops, having an understanding of the soil conditions and characteristics over a large spatio-temporal scale will definitely help with that decision making. And then overall looking at the important influence on the climate system. So soil moisture over a large spatio-temporal scale does have an effect on the climate systems. So this obviously for hydrological studies and how the climate is changing, being able to understand soil moisture fluctuations should shed some light and provide more information about characteristics of a climate system. So, and then kind of looking at my relevant experience. I don't have any work experience using this technology, but I did conduct a senior thesis for my earth science geology undergraduate at Wright State University here in Ohio, where basically I used INSAR, or interferometric synthetic aperture radar. It's free software just provided by the European Space Agency. It's called SNAP. And I basically was just trying to determine the software applicability. Could this be something that could be applied, in an educational setting, and students would be able to use easily in their remote sensing courses. Was this something that could be used to develop interferograms and have a better understanding about how INSAR works? I did run into a couple hiccups, so definitely some areas that still need to be researched further. But so this study was conducted through the geophysics department at Wright State University as part of my senior thesis. And this is kind of really the only major exposure I've had in a formal education setting to remote sensing technology, but no professional or related work experience, I should say. And then just here's a link to that paper, so if anybody was interested in reading that, they could, of course, click that, and you would have access to that. You could read that. And that basically concludes my presentation. Here are the references used. Thank you. And if there are any questions, feel free to send me an email or comment, and I will try to answer them to the best of my knowledge. Thank you again.